Good morning, everybody. Today we are going to solve an exercise about chemical reaction. Given an iron sulfate solution FeSO4 with concentration 0.1 mole per liter and volume V equal 20 milliliter. This solution is mixed with another solution, which is sodium hydroxide NaOH with concentration 0.1 mole per liter and volume V equal 30 milliliter. Upon mixing both solutions, a chemical reaction takes place which is observed by the formation of a green precipitate of FeOH2. In part 1, write the balanced chemical equation. To write the equation, you have to start by writing the reactants FeSO4 plus NaOH. After the arrow, you have to mention the products. The first product is the green precipitate FeOH2, which has a solid state. But it's not the only product in this chemical reaction. The second product is between Na plus and SO4 2 minus, which leads to the formation of Na2SO4. Don't forget to mention the physical states of the other substances. Now you have to balance this reaction. Here we have 2 Na in the products, so we have to multiply Na here by 2. By multiplying NaOH by 2, so now we have 2OH, and in the products we have 2OH. So now it's a balanced chemical equation. Here we have 1 Fe in the products and 1 Fe in the reactants, 1 SO4 in the reactants, and 1 SO4 in the products. In part 2, identify the type of the given reaction. It's a double displacement reaction. Why it's a double displacement reaction? It's between two compounds where two elements replaces another. In part 3, calculate the initial number of mole of each reactant. In the first reactant, what do you know about FeSO4? We know that its concentration is 0.1 and its volume is 20. So according to the rule, N equal C times V. So equal 0.1 times 20 times 10 power minus 3, since we have to convert it from milliliter into liter. So the final answer is 2 times 10 power minus 3 mole. The same with respect to the second reactant, NaOH equals C times V. Its concentration is 0.1 and its volume is 30 milliliter multiplied by 10 power minus 3. So the final answer is 3 times 10 power minus 3 mole. In part 4, deduce the concentration of each reactant in the initial mixture. Upon mixing both reactants, the total volume of the solution changed. So it becomes 20 plus 30, which is equal 50 milliliter. And this change in the volume of the solution leads to the change of the concentration of FeSO4 and that of NaOH. So to calculate the new concentration of each reactant, you have to use the rule number of mole of FeSO4 divided by the total volume of the solution. Its number of mole remains the same, 2 times 10 power minus 3, divided by the total volume, which is 50 times 10 power minus 3. So the final answer is 0.04. Don't forget that the volume should be in liters. Concentration by the same way, the concentration of the second reactant, NaOH, now it's equal number of mole of NaOH divided by the total volume. So the final answer is 0.06 mole per liter. In part 5, specify whether the initial mixture of reactants is stoichiometric or not. If not, identify the limiting reactant. To verify whether it's stoichiometric or not, you have to calculate the ratios of both reactants, FeSO4 and NaOH. The ratio of FeSO4 is equal to, refer to the chemical reaction, it's equal to the number of mole of FeSO4 divided by 1, since the coefficient here is 1 beside FeSO4, which is equal to 2 times 10 power minus 3. This, by the same way, we calculate the ratio of NaOH, which is equal number of mole of NaOH divided by 2, since here we have a coefficient equal 2. So the final answer is equal 1.5 times 10 power minus 3. Since both ratios are different, this indicates that the reactant mixture is not stoichiometric. To identify the limiting reactant, you have to compare both ratios. The reactant which takes the lowest ratio is the limiting reactant. Since the ratio of NaOH is less than the ratio of FeSO4, then NaOH is the limiting reactant. Don't forget that the limiting reactant is totally reacted at the end of the reaction, while the excess reactant FeSO4 apart from this reactant will remain at the end of the reaction. In part 6, determine the molar concentration of Fe2 plus ions at the end of the reaction. FeSO4 is an excess, is the excess reactant, which means that a part from FeSO4 remained at the end of the reaction. So in the first step, you have to calculate the remaining number of mole from this reactant FeSO4, which is equal to the initial number of mole minus reacted number of mole. Initial number of mole which is calculated before, and the reacted number of mole which can be calculated by using the stoichiometric ratio. You have to take it with the limiting reactant NaOH. So number of mole of FeSO4 reacted over 1 is equal to the number of mole of NaOH reacted over 2, since the coefficient beside NaOH is 2. So the final number of mole of FeSO4 reacted is equal to 1.5 times 10 power minus 3 mole. So finally, to deduce the number of mole of FeSO4 remained, you have to subtract the initial number of mole minus the reacted number of mole. So you will get 0.5 times 10 power minus 3 moles from FeSO4. Now, to deduce its concentration, you have to use the rule number of mole divided by the volume of the solution, by the total volume of the solution, which is 50. So the remaining number of mole is 0.5 times 10 power minus 3 divided by the total volume of the solution, which is 50 times 10 power minus 3. So the final answer is 0.01. From FeSO4, you can deduce the concentration of Fe2 plus in the final solution according to the ratio of the dissociation equation. So the concentration of Fe2 plus is equal 0.01 mole per liter. In part 7, calculate the actual mass of the precipitate formed, which is FeOH2, if the yield of the reaction is 80%. Let's revise the rule for the percentage yield. Percent yield is equal mass actual over mass theoretical times 100. It's the actual quantity over the theoretical quantity. The actual quantity here we can calculate it, since we have given that the percentage yield is 80%. And we can calculate the theoretical by using the stoichiometric ratio. So according to the stoichiometric ratio, you can calculate the number of mole of FeOH2 formed by taking it with the limiting reactant NaOH. So its number of mole is 1.5 times 10 power minus 3 mole. From its number of mole, you can deduce the theoretical mass of FeOH2, which is equal number of mole times molar mass equal 0.135 grams. So now substitute the theoretical mass in the equation of the percent yield, and the percentage yield is 80, then mass actual is 80 multiplied by 0.135, and the final answer is divided by 100, so you will get 0.108 gram, which is less than the theoretical quantity.